We're joined this morning by Stuart, who works in aviation, as you can see from the very exciting image on your screens. And Stuart works as a radio engineer. So we're going to find out a lot more about Stuart's role and the work he does. So without further ado, I'm going to pass you over to Stuart. Good morning, Stuart.
Morning, thanks, Lydia. Yes, good morning, everyone. I hope you're doing well. Welcome to my office, which is actually a spare bedroom in my home. Historically, I have worked in a different office, but because of all the coronavirus issues, most of my organisation is working from home. So this is where I spend most of my days in front of my computer at the moment, but very much looking forward to getting out and about a bit more in the future. So yes, my name's Stuart. I am a radio engineer, and so my job is all about everything that is wireless. And I'll just talk about this first picture on the screen in case you're wondering what it's about. This is a real aeroplane. It's an Airbus Beluga, and this aeroplane is designed to carry other parts of aircraft between aircraft factories. So it's got this big door at the top, at the front. And that whole thing, the hatch comes open, it flips forward, and then they can load parts of aircraft into it to shuffle bits between different factories, because an aircraft isn't necessarily made in one single factory. Different parts of an aircraft are made in different places. So wings for aircraft are made in Wales, and then those wings are shipped across Europe to other places where they've built other parts, where they've built the engine, where they've built the main part of the aircraft, and then they're all assembled together in one place. So this is my favorite aircraft. I think it's a fantastic piece of machinery, great feat of engineering that they've managed to build something this big, and the fact that it looks like a beluga whale, and it's got the eyes on the side and the cockpit that makes it look like a mouth, I think is just a nice touch. Just move forward to my next slide. So my job is to do with everything that is wireless. There are hundreds and thousands of things, and we use things every day that are wireless, and they use radio to communicate to make that happen. So I've got a few examples on the screen. So I'm sure all of you probably have Wi-Fi at home, which is probably one of the most kind of prevalent uses of radio that we have today. And that allows computers, tablets, games consoles to connect to the internet, which is a really important part of our life. Other things that we use, obviously, you can see, if I just show you what I'm looking at. So the mobile phone, many of your parents will have a mobile phone, and it is a really important part of our life. And again, a mobile phone, it needs to communicate in order to make phone calls and search the internet and use apps when you're out and about. And so a mobile phone will communicate wirelessly to a mast, which you may have seen around your town or village, to do what it needs to do. A few other things. So a car radio, generally this is one of the main places where you'll find a radio these days. A lot of people use smart speakers to listen to the radio, but you'll still find radios in cars, and they still rely on music and sound to be sent to them wirelessly in order to listen to the radio when you drive. And things like car key fobs, again, radio waves are used so you can unlock the car. TV, so whatever channel you're watching, unless you're watching it on iPlayer or Netflix, if you're watching it live, it will rely on radio waves to do that. So you're watching me now, and for me to get to you will involve several different pieces of radio to do that. So my headset is wireless, so it communicates to my computer. My computer has Wi-Fi. It communicates downstairs to the box that provides me my broadband, my hub, and then that goes back across using wires to get to the other side. Pops out in your school, and then no doubt you're using wireless systems to get it through to your screens at the other end. So radio is really important to what we do in our everyday lives now. It's really, really important. So my job is all about radio. One of the things that really need to be wireless our aeroplanes and all things aviation. I don't think it would work particularly well if we were dangling wires from underneath aircraft to communicate with the ground. And so I work for an organisation that effectively looks after aviation in the UK. We make sure that everyone's following the rules. We write new rules if we need to. And we generally make sure that the skies are kept safe. So for most of us, if we think about the word aviation, we will think of something like this. So a big, what we call a commercial airliner. So an aircraft that will carry hundreds of passengers, whether they're going on holiday, going to see family. It might be an aircraft which doesn't have any seats and it's transporting goods across the world. So, for example, I imagine a lot of you might have had a banana this morning. That banana wouldn't have got to you if it wasn't for an aircraft carrying it through the sky. So we use big aircraft for a number of things. But for my job, I'm interested in all different types of aviation. So although a commercial aircraft like this is probably what we see the most day to day, I'm also interested in other types. So you can see up in the top corner, hot air balloon. We look after what we call recreational aviation, so aviation that people do for fun, for a hobby, whether they're in a hot air balloon or a glider or a small aircraft. We look after a growing area which is drones, or as we call them, unmanned aerial systems. I prefer drones. I think it's easier to understand. And drones are not just used for fun, although a lot of people have them and they fly them for fun. They are used for a lot of different purposes now, where we can use them to effectively keep people out of danger. So whether that's using them for photography, aerial photography, they're used to inspect things like power stations. So instead of sending a person on a ladder or a piece of machinery to go and look and inspect an important wall or bridge or something on a power station, we can use a drone with a camera to do that. They're used to look at wind turbines to make sure they're operating properly. They are literally used for thousands of different things. So in my job, I look after all these different parts of aviation to make sure that they can operate. And radio waves are used for a number of different things to enable or allow aviation to do what they need to do. One picture that isn't on here, which the civil aviation do look after, which is a relatively new thing for us, is space travel. So we are what we call the regulator, so the organisation that writes the rules and makes sure everyone follows them for space travel. So in the future, we will be looking after companies that are sending space launches up from the UK, whether they're launching satellites or they're launching people in space planes to go up into space. And enjoy and conduct science experiments and generally look at how the world can be improved by using space travel. I'll just talk very briefly about what the Civil Aviation Authority does. So as I say, we look after all parts of aviation in many different ways. So we look after what we call the licensing of pilots. So it's a bit like when you have a driver's license. We are the organisation that sets the tests and exams that a pilot has to do before they qualify, before they can fly a plane. And we're also in charge of making sure that they are maintaining their knowledge and experience, that they're still able to do their job, and that they're fit and healthy in order to do that. We look after what we call the infrastructure that enables airplanes to fly. So whether that's the runways, management of the skies above us, to make sure that aircraft are flying in the right place and that there isn't any risk that they crash into each other. We also look after cabin crew. Cabin crew are really important. So a lot of people think they just provide drinks on an aircraft, but they are really integral into making sure a flight is safe and that it's conducted in a particular manner to make sure everyone's kept safe. We look after airports. We make sure airports are accessible for everyone that wants to use them. So we go into airports and we check that if you have a disability, you can still get through an airport and you can go in there and use it. We also make sure we look after security for aircraft as well. So if you've ever been on an aeroplane and you've been through an airport and you've been through the metal archway and had your bags x-rayed, we write the rules and make sure that airports are doing that correctly. So the Civil Aviation Authority does all sorts of different things. Aviation means we look after aeroplanes and all other types of flying objects, apart from birds. Authority means that we are effectively in charge and we write the rules and check people follow them. And civil simply means things that are used by everyday people. So broadly, that means not military. So we're not in charge of the RAF, the Royal Air Force. We just look after the stuff that serves society in general. So not the military. So that's where our name comes from, and that's what we do. I'm just going to take you back slightly and talk about how I got into being a radio engineer. So two pictures here. The picture on the right, I don't know if anyone has got one of these now. This is an electronics kit. So it contains different gadgets and parts that you can use. And I used to have one of these when I was younger. And I used to make something called circuits, which is when you combine all the things within this kit. You use little wires to join things together, and you can make basically machines that do different jobs. So I used to make burglar alarms for my bedroom to stop my sister breaking in and stealing my toys. I used to build radios to listen to music on an electronics kit, and I got one when I was quite young and I really enjoyed it. The picture on the left is a whole load of different types of radio that you can use to communicate with people across the world. My dad was into radio communication. He was something called a radio amateur, and I was fascinated by the equipment and the gadgets that he had in his study, and the fact that he could listen to people across the world and talk to them. And what they used to do is he used to talk to them, and using his equipment and the aerials that are out in our garden, and then the people that he spoke to, they used to send postcards to him. So he had this big display of postcards of all the people that he spoke to, and I was just hooked on the idea that you can communicate people and use radio to do that. So I started getting interested in that. I studied physics and maths at school, which are two things that are quite critical to understanding radio communication. And I studied electronics engineering at university and kind of specialized in the work of radios and how they operate. My first job after university wasn't anything to do with aviation. I actually got a job building television studios and TV stations. So some of you might recognize this building here. This is the BT Tower up in London, one of the tallest buildings in London. And this is me on the 35th floor of that tower, where I built a TV studio for a channel which is called BT Sport. So if some of you watch football at home, they will use the television studio that I helped build. I also did some work overseas. I worked in a country called Angola, which is in West Africa, and built one of the first television studios there. And that picture down there on the bottom left is me over 10 years ago in Angola building that TV studio. So for me, this was a great first job because it was all about communication and broadcasting useful information to people across different countries in the world. After that, I worked at an organisation, or it's actually a part of the government. So it's called the Home Office. So effectively, I was working for the Prime Minister, so the Boris Johnson of their day. And my job was all about using radio waves, using wireless bits of equipment and things to make people safer. So you can see me here outside 10 Downing Street. I was looking at the CCTV cameras there. This is me doing various bits of work. So this is the Olympic Park up in London, and we were helping out with some of the communication there to keep people safe. And I used to do a lot of work with the police to make the equipment that they use work correctly. So their radios, and interestingly, some of the equipment that the police use to spy on people, if there's criminals that they're trying to gather evidence and find out what they're doing. I used to support the police doing that. So that was where I really got into radio. And then I moved into aviation about 6 or 7 years ago. And so my job is to look after all the different systems that they use to support aircraft in the sky. So I've got a few pictures here. And generally, so my job, we call it communication, navigation, and surveillance. So those three words are all very long, but they're very simple. So communication simply means people being able to talk with each other. So that whether that's an air traffic controller talking to a pilot, to make sure they can direct them to go the correct place, or whether it's two people trying to move an aircraft on the ground. That's the communication part. It's not just voice. Not many people know that pilots also use the equivalent of text messaging to talk to air traffic controllers. So they have a computer in their cockpit and they can send text messages to air traffic controllers, and the air traffic controllers can send messages back to them to tell them to go up, to go down, to go left and go right, and make sure they're in the right place. So that's communication. Navigation is all about aircraft knowing where they're going. So that might be a word you're familiar with. And because aeroplanes have to be very safe, we have several systems for navigation to make sure aircraft always know where they are. So it's something we call redundancy. It basically means there are backup systems for people to use. So typically an aircraft will use GPS or satellite navigation. So it's very much like the sat nav that you might find in your parents' car, except it's built for aeroplanes. So instead of having a map of the roads on the ground, it will have a map of the skies and tell pilots where to go. And they can program their satellite navigation system to tell them what to do, and it will tell them where to go. So that's predominantly the system that's used by pilots today. There are other systems, what we call terrestrial navigation aids. Terrestrial just means they're on the ground, and there are other systems which effectively an aircraft can use. They send a message to a transmitter or an aerial on the ground, and then that aerial on the ground replies and tells them where they are. And those are some of the older systems that we used to use. So that's navigation. The third one is surveillance. And surveillance, although it sounds like a complicated word, all it means, it just means about watching people. So if you are surveying someone or you're using surveillance, it just means you're watching them. So we watch aircraft in the sky, and that's what the picture here is. That's a radar. So to watch aircraft in the sky, we use radar to do that. And so my job is all about looking after radars, making sure they work correctly, and that they function as they should do. And all a radar does, again, using radio waves, they fire radio waves out from themselves. So you can't see them, they buzz through the sky, and anything metallic they bounce off of. So they will send a beam of radio wave into the sky, and if there's an aircraft there, it will bounce off it, and then the radar will work out and calculate where that aircraft is. And so I look after all of these things, make sure they work properly, but also develop new systems. So the team that I work within, we are constantly looking at new systems to improve the way aircraft communicate and navigate to make it better. And that's a really important part of my job. So we're already working on new systems for aircraft to use that will allow them to fly in a more efficient way, to fly in a safer way. And so a lot of my job is about looking to the future to look at what aircraft need to do. And we know that aviation has a particular challenge when it comes to the environment. They have a very poor reputation because they are big polluters, and some of the developments in these areas that I've talked about will ultimately help aircraft become more efficient and fly in a much better way. So that's my job. That's how I got here. And I think now we're going to have some questions if you've had some through.
That was brilliant. Thank you very much, Stuart, and really interesting to hear all the different ways that radio is used and how your job has come from that electronics kit, which is absolutely amazing. And we've actually had a question come through about that electronics kit. How has the technology changed from when you were a child to now?
Quite a lot. So I'll tell you a secret. I'm 37 years old. So I was born in 1984, and I was probably playing with that electronics kit in about 1990, so 30 years ago. And when I was building circuits, then you use lots of individual components. So to create something like a burglar alarm or another gadget that you wanted to use. And gradually over time, a lot of those components have been replaced by chips that do that job for you. So we call them integrated circuits. So they are, where I'm building circuits with lots of little components, typically these days they are integrated into a microchip. So instead of building a radio, you will just buy a little microchip that is a radio, and you connect a few wires, you power it up, and then it does what that circuit used to do. So that's happened over time, and more now, most electronics things that we buy are effectively computers. So if we think about your smart speaker that you might have, all that sits inside that, it will have a speaker to make the noise, but a lot of what that does will be one chip, which effectively is an entire computer, and it does everything that it needs to do. So for me, electronic engineering has become more and more about how you program the computer that's inside those devices. So I think that's the biggest change that's gone on since I was tinkering around with my electronics kit.
That's a big difference from lots of wires, I suppose. Really impressive. Just shows how technology changes. So thinking about, I think this question is thinking about the Civil Aviation Authority, and they're wondering, is it the same rules all around the world, or do the UK have their own rules?
So it's a mixture. So we're the UK Civil Aviation Authority, but there is actually an organisation called ICAO, ICAO, which is the International Civil Aviation Organization. And ICAO is an organization which is part of the United Nations, which is like a worldwide, almost like a government across the world, and they try and encourage people to do the same things. So you've probably heard a lot about the World Health Organization, which again is another what we call a UN agency, and it's in charge of health. There's the equivalent of that for aviation, and they do write a load of rules. They're called the ICAO annexes, and typically in the UK we try and follow those rules developed by the International Civil Aviation Organization. Occasionally we do have a requirement to do things slightly differently, and if that's the case, what we will do is we will tell ICAO that we are doing things slightly differently. So we will say, for this specific thing here, we've got slightly different rules, and then we will have a UK rule to do that. But typically most of the rules in the UK will be the same, because obviously aircraft typically don't stay in the same country. They can go through, you know, tens of countries through one particular flight. So it's really helpful if the rules are the same, something we call it harmonization. So it means that the rules are the same everywhere you go, and that so an airline or an aircraft doesn't have to change what it's doing as it flies across the world. But there are little differences that we make, but we try and keep it to a minimum.
We have a question come through from Darnley Primary, so they've let us know where they're coming from as well. Good morning to everyone in Darnley Primary. Wondering, what did you do to help build a TV studio in Africa?
What did I do? So when it comes to building a TV studio, the most important thing is the design of it. So there's a lot of work to we use computer software effectively to create a wiring diagram. So it's about connecting different bits of equipment together. And back in the office, we did a lot of work producing really big drawings. I've still got some of them in the cupboard, which show you how we're going to wire together all the different machines that we use. So that might be a video camera, a video recorder, the system that actually creates the radio waves, and we design all that in the office. And then when I was out in Angola, effectively it's all about putting different parts of equipment, connecting them together in a particular way to get them to do the job that you want it to do. So, and then all that equipment needs to be set up correctly. So as an engineer, my job is predominantly to take each individual bit of equipment and kind of program it, configure it so that it does the job that we need to do, and that it will talk to the other bits of equipment that it's connected to. Broadcast engineering's really enjoyable. But it can get quite messy because you need so many wires to build a TV station. Most TV stations have what we call false floors. So you lift the floorboards up and there's a big gap where you lay all the cables to connect everything together. So that's kind of the main part of my job, designing how we're going to connect it together and then programming everything so it talks to each other.
Brilliant. And I think that kind of leads on actually to the next question we've had come through. So with your job now, how much of your work is hands-on, or do you do a lot of work on a computer?
So most of my work is on a computer. A lot of the work I do is about writing rules, about talking to other organizations about how they're doing things. So it's very much me talking to people and writing reports, generating diagrams to explain things to people, presentations to explain things to people. So I don't have much time now kind of hands-on with a toolkit in my hand, but I do get to visit different airports, different places, and look at how they're doing things, check they're doing it correctly, and things like that.
Brilliant. We're thinking now about the environment, I think, in the Q&A. So we've got a question about what kind of things can airplanes do to be more eco-friendly?
That's a really good question and very, very topical after we had the big conference a couple of weeks ago. So airplanes are they can be very bad for the environment. There are a number of different technologies that is coming. It will be a few years. I would say the most important thing we can do is really think about when we need to fly, and if we need to fly. At the moment, that's the number one thing we can do. In terms of other things that are happening, so electric aircraft is something that's coming. So exploring different types of fuel is going to be really important. So I know the companies that make engines for aircraft, they are looking at using different types of fuel. So they're looking at using a fuel called hydrogen, which has significantly lower carbon emissions than the fuel they use at the moment, which is called kerosene. There are companies looking at using electric aircraft, and there are companies looking at something called sustainable aviation fuel. So sustainable aviation fuel is effectively what we call a biofuel. So it's made from oils from crops. So rapeseed is one of the crops that can be used to make sustainable aviation fuel. And manufacturers that make engines, they are already producing engines that can run on sustainable aviation fuel. So I think the next step will be for aircraft to start mixing their traditional fuel with sustainable fuel in greater and greater quantities to make it more sustainable. And so those are probably the main things that are going to happen. There's lots of kind of smaller things. So I mentioned about how if we can improve the systems that aircraft use to navigate where they're going, we can allow them to go directly from one airport to another. At the moment, what they do is they'll come out of the airport, they will follow what we call waypoints, so they will kind of go in very straight lines between places to get there. And when they get to the airport they're going to, they might be in what we call a hold. So they'll be above the airport, but going round and round, whilst the airport creates space for them to land. And obviously the more an aircraft is doing that, the more fuel it's burning. So if we can reduce the amount we hold aircraft, if we can make them fly more directly, it reduces the carbon that they're emitting. And there's hundreds of smaller things that are quite complicated, some of them, but they give us gains in terms of improving aviation. Building aircraft from lighter materials is one of the things that we can do to reduce their carbon footprint. Making them more aerodynamic is another. So there's literally hundreds, but I think moving away from the fuel they currently use is probably going to have the biggest impact.
Super. And we've got a couple of questions about the future. So where do you see your job as a radio engineer in the future? And also, do the radio waves go all the way up to space?
So where I see my job in the future, I think more and more, I think we'll rely on satellite navigation more and more. So I think my job will become more and more about satellite navigation. And also what we're looking at is that we have systems that can do multiple different things. So instead of having one system for airplanes to talk to pilots and one system for them to navigate and one system for radars, we're looking at systems that can do more than one thing at a time. And do lots of different jobs at the same time. So I think it will be more and more about satellite navigation, and there'll be more systems that can do different things. And I think that will be the way my job is going. Aviation in general is massively changing. There's lots of potential for automation to come in, lots of opportunities there, and just I think different technologies being used to do the jobs that we currently do. So we are becoming more and more about drones. Drones can do more and more every day. They can do things that aircraft, that it's more dangerous to get aircraft to do or to get people to do, whether they're climbing up a ladder. And so I think we'll become more and more a society that uses drones and what we call autonomous vehicles that can fly themselves to do some of the jobs to keep people out of harm's way. Second question, you might have to remind me, Lydia, what was the second question?
No problem. It was about the radio waves and can they go all the way up to space?
Yes, so absolutely, radio waves can go all the way up to space. They have to be quite a specific type, and they have to be quite powerful. They have to have lots of power to get up into space. But yeah, we can use radio waves in space for all sorts of things. So whether that's sending them up or listening to radio waves from space. So if you look at when we do fly to Mars, we will need to talk to those astronauts. We will want to see video coming back from them, and we'll use radio waves to do that. We're already using radio waves for space. So I mentioned satellite navigation. So if you've got a sat nav in your car, that comes from space. So your car is picking up signals that are coming from satellites in space to do the job that it needs to do.
Brilliant. And a couple of questions that I really love, and these will be our last ones for you, Stuart, are about your favourite things. So the first one is from Darnley Primary again. What was your favourite subject at school? And then the other favourite is what's your favourite part of your job?
Okay, so favourite subject at school was definitely science. Loved science, and particularly a part of science called physics, which is all about how forces work, and physics is where there's a lot of stuff about how radio waves work and a lot of stuff about space. So I really loved physics at school, but I loved science in general, but particularly physics. Favourite part of my job, I think the favourite part of my job is probably kind of generating new ideas and seeing technology progress. It's really exciting when you go to a meeting and we're talking about the new technology that's going to come in and what that technology can do, and being a part of kind of developing that, particularly where you can really see the benefits. So to be part of developing a technology which is going to reduce the environmental impact of aviation, I think is really exciting. I feel quite strongly that aviation does have an impact on the environment. I don't think society could necessarily survive without it. So it needs to improve, and to be part of that, to make that difference, I think is really exciting.
Fantastic. Well, thank you to everyone who joined us this morning for all your fantastic questions. And most importantly, thank you very much, Stuart, for joining us. It was so interesting to hear all about your job and what the future might look like as well. So thank you everyone for joining us, and thank you to Stuart.
Thanks guys, have a good day.